there's really two parts to 12-2. We're only going to get to the first half of it today. Not a big deal. I really like to take time going through the first, a lot of this probability stuff. I think that it's something that you guys really don't get a chance to see a lot of. It's a petition. For what?
What is it?
Wait, what? It's a petition to
Get more questions than that. I'm on my third
Like
page.
fresh, not like in the packaging.
Like they said,
I
it's like
apples
nose
are
and
fat.
food.
Yeah, that way we would have guavas, mangoes.
Did you like talk to
They're not gonna get long.
You
You
talked
talked
about
about
roses.
Yeah.
We can't
And she
afford
just said you gave
strawberries.
No, she said I'm meeting, said I'm meeting with the chart level people who make our lunches, and so I'm just making the petition, like, I don't think the petition on its own is gonna, like, actually help, but I think, if I have a petition, it can show that,
We need to
a
buy
lot
it.
of kids do wanna eat healthy, and if we gave them healthy food, they'd eat it.
It's true. It's true. And I've always thought that with yesterday. Yesterday we talked about permutations. Permutations had a little bit of a twist to them. Order was specific within a permutation. I think I used the analogy with you guys yesterday that a combination lock should be called a permutation lock because the order in which you put your com in opens the lock. Whereas a combination, the order of the numbers wouldn't matter. So your three values, 13, 7, 22, whatever it might be, when you put those in any order, the door would open.
So right now we're just doing combinations.
Today we're talking about just combinations. And I'm going to introduce you guys to a very small values of probability. It's not really in this section a lot. We're just going to talk a little bit about what it means and how you can find them and kind of work through some of these things. So combinations, tomorrow we'll talk more about binomial theorem. Binomial theorem is how to take a binomial, a term, raised to a power. For example, if it was 2x minus 4 to the 8th power, and I was going to ask you to multiply that out. Well, first of all, you get really, 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 really upset with me,
Yes.
because that's a lot of foiling and combining like terms. Well,
Stuff like that on the party.
was there? There is something, it asked you what was the third term or something like that in it. There is a way of doing that with binomial expansion. They're actually just finished up doing some of that in pre-calc like a week ago. I know that one of the kids came back to me and said, hey, the way that you showed us how to do it last year was so much easier than what they were trying to do in pre-calc because they tried to go this whole long way of doing it. And I'll show you a really nice shortcut. Now, maybe you'll remember it for next year.
Next year will we be allowed to?
I'll write a limit on it.
Why wouldn't you be?
Because they're saying they have to use a one after each one.
I don't know.
They just have to listen
Maybe
to
they
the
should teach the teacher. Don't they have a son anyways to agriculture?
All right, now they do, yeah. What's that?
Maybe they should teach the teacher.
Well, they don't. That's, but it's,
Yeah,
well, the thing is that the class that we're doing is the one that has a sub right now, so they might not know the shortcut. Yes, ma'am.
This is like kind of not related to this, but are you right now? Are you the only honors algebra 2 teacher?
Yes, I am.
So no one else teaches honors. There's other algebra 2.
Correct. Yeah. Yeah. The other two teachers would have been Fontana and Plascota. Solano, who's not here anymore, he used to teach the AB, which is the kind of a little slower paced
They
one.
have algebra 2 AB.
Yeah. It's the same content, just at a slower pace. They might not get through as in depth the things that we did, So, think about conics. We did all of that. We did a lot of extra sections that other people didn't do. So here's what we're looking at.
Selected honors algebra 2 and the teacher.
Yeah. What we're looking at here is, don't write all this out here, but remember that combinations are just picking things. You wanted to go and select 3 ice creams out of the 31 flavors. Does it matter the order in which you pick the 3 ice creams? That is Baskin Robbins, okay? It doesn't matter. The order is not important with a combination. So a really nice way of looking at it is that they have a formula for combinations. Like yesterday we had that NPR, number of objects, permute, R times. This is the number of objects, combination, R times. So it's a very easy formula to work with. We talked yesterday about being able to crank some of these out by hand. We can do the same thing with combinations, and it's actually even easier. One of the best examples that I can come up with for talking about combinations is working with a deck of cards. And in this class, I'm going to hope you guys know what's in a deck of cards.
Yes.
Cards! Way to go!
Yay.
52
cards or suits.
So, just so we remember, deck of cards. Deck O cards.
You put the apostrophe wrong side.
Assuming.
The thing replaces the F, which comes after
I really don't think he cares.
I think it's really going to bug her,
I think
so
it's really bad.
just so I don't have to deal with it, it's easier just to kind of give in.
Thank you.
You're welcome. Now, I mean that nicely. How many cards? How many cards are in a deck?
52.
You ever played 52 card pickup?
Yeah, let's do it.
I can't shut up.
52 card pickup is the most fun card game ever.
So you gonna do it?
So we have 52 cards. How many suits are there?
Four.
You have 4 suits. You have
12.
diamonds.
Oh, 13, you're right. 13.
You have diamonds. I'm not there. Hearts.
No, spades. Spades. You have to look at it to be able to draw it.
It's a hard
The
thing.
thing that looks like a leaf.
Yeah. No.
Upside down.
Spades.
Ah, look at that.
Upside down.
I don't look at a club here because I don't get really good at these either. Let's see.
Really?
What do you mean, dang it?
It's pretty bad.
It looks like a dying child. I don't know. What? What way is this child dying?
How did it?
No amount of squinting and closing one eye and sitting sideways.
You have to close both eyes and imagine it.
It looks like a mouse, like the left one on the top one of the ears, and then the right one is like.
The third one looks like it looks like a whatever it is.
Well, that's the therapist office. That's not like what I see.
Now, what I want you guys to see here is that half the deck card is black, half the deck card is red.
Yes.
You can see that a lot with probability stuff, so remember that. There are 13 cards in each suit. You have the numbers 2 through, oh, there's no 1. 2 through 10. Then you have Jack, Queen, King, and then the Ace.
Doesn't ace work as a one?
I don't know, do you guys want to call Ace a face card?
Yes.
Yeah, sure.
Yeah.
Yeah.
What is that?
It's high value.
Or low value?
You know what's a fun game?
When you're playing Smash Bros, it's nice to have the option.
Yeah, I didn't know it's 11 and
We might.
Let's play Go
Now-
Fish. Let's play Go Fish.
There's no dice cubes in here, or no number cubes, excuse me, there's no number cubes in this class. Now, one of the things I like to talk about when we're looking at a deck of cards is how many ways 5-card deals are there? A lot, yes, you're right. Merry Christmas. What I want to see is, does the order matter in which I'm dealing cards?
No.
no.
Why?
Because you can do the same thing, but you.
You can't repeat them because they've already been.
They've already been dealt out. And even though you deal out the first card, you go 1 through 5, can't you rearrange them in your hand anyway?
Yeah.
All right, so if I take out a card, there's 5 cards. Well, this is 1 possible hand.
You got a lot of nines.
Wow.
Almost a full house.
It's 3 9s, not too shabby. So I have 3 9s here, woo woo. I would probably keep this hand and keep going. Now,
You shovel it like spoons.
what I want to think about here is,
No one goes-
I'm not repeating anything. The order in which I'm not repeating, I'm not the order in which I'm dealing those cards out doesn't matter. So how do we figure out then, how many possible are there? Well, how many cards are in a deck of cards?
52.
52 of them. So if I have 52 total cards, how many am I choosing when I'm dealing 5?
5.
Choose 5. Now I'm going to show you how to do this long form. So if I'm going to do this long form, remember it's going to be 52 factorial over 52 minus 5, oops, that minus sign, factorial times 5 factorial. Okay? $52 factorial is just 52, 51, so on, so on, so on, all the way down the line. Correct?
Yeah.
What's 52 minus 5?
47.
So that's 47 factorial.
That's a big
So
number.
it's just 5 factorial on the top, and then it goes.
Whoa, 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 whoa.
No, it's 52, 51.
So what?
So 6.
8.
What?
Take a look what happens here. 52 factorial is 52, 51, 50, 49, 48. I can stop there because
Yeah.
47 factorial would simplify out with 47 factorial coming down here. You guys agree?
Yes.
See,
Now that means all I'm dividing by then is 5, 4, 3, 2,
120.
1.
Well, that's all.
Okay, you're right. But I'm going to simplify it further.
Yeah, you're gonna go.
So make your lives a little bit easier. What's 5 times 2? 10 goes into 50 how many times? So I'm going to replace the 5, the 2, and the 50 with a 10. You okay with that?
Yeah.
Not a 10, a 5.
Yeah, I was
excuse me.
gonna say.
I was like, I'm not okay with that. And then 4 times 3 is 12.
And 12 goes into
48.
how many times?
4 times.
that's a big number.
So now my answer, if you didn't have a calculator, would be 52 times 51 times 49 times 20.
You get 2.5.
2,598,960.
You still get a really giant number, but let's say I didn't give you a calculator. Would you still write all that out?
Yeah.
Yeah.
It's not a difficult thing to do.
It take me a couple minutes to.
You get a little practice. So this is telling us that the number of possible 5-card hands
Oh, shucks.
is 2,960,000.
598,960.
Okay. Yes, ma'am.
Wait, so on tests, would you accept the 52 times 51 times 49 times 20 as an answer, or do we have to go ahead and multiply?
It depends what I give you. Depends what I ask.
Calculate.
If I ask you to without a calculator, then yeah.
Or no?
I don't expect you to multiply that out by hand.
Thank you.
Can I?
That is.
Good save. All right. Let's go a step further.
Wait, wait. Random.org.
Yeah, it's just card decks. It's not as nice as I anticipated. I put it in there, and it's ugly. Now, here's what I'm going to ask you. How many of these 2 million some odd hands will give you all 5 cards in the same suit? You know what that's called? All the same suit?
Flush.
Flush, very good. Flush is good.
Yeah.
Is royal flush when they're all in order?
When they're all.
Is the red flag is
A royal flush is ace through 10. A straight flush is any of them in numerical order. The same suit.
Full house.
Full house is
3 and 2.
Yeah.
That
So-
was a lot.
2 the same and 3 the same.
So if I'm looking at this as, how many of these are all 5 cards the same suit? Well, to get 5 cards the same suit, it's tough. Stop thinking. This doesn't happen very often. Okay? If you've ever done any, we wouldn't say gambling, but if you ever played poker, it's not a very common thing to see. 2 pair, 3 of kind, things like that's a lot more common than a flush. Flushes aren't very often. So you have to figure out, well, in order to get a flush, you have to first pick a suit. Do you agree?
Yes.
So if I flip over this card, what is it?
Spade.
A spade. So right now I have chosen a spade, so I'm only hoping
No.
Ooh.
Oh, and it's 2-3.
2-3 spades right now.
Come on, do it again, do it again.
Oh!
What's
But
your plan?
I have 2-3-5, which means I'm still in the possibility of getting a what? Straight. A straight is what?
It's
Four.
It's
Five
five.
and a
Consecutive number. So I'm hoping for like a 6 or a 4 here.
Oh, that's an 8. Oh.
You can still get a pair.
9. So I'm done.
You gotta
But
skip straight.
you know, it'd be great if it was a skip straight, but that'd be bad. Because then I would get shot because I would have cheated. And I would have died of dysentery or something.
Dysentery.
So, in how many of these hands are all 5 cards the same suit? So think about what you had to do there. What was the first thing you had to figure out?
What suit?
What suit? So how many suits are there?
4.
4 of them. So you had 4 suits, you had to choose one. Do you agree?
Yeah.
Yeah.
So you wanted 2 things to happen. You wanted you have 4 suits, you chose one of them, and you wanted something else to happen after that. What was that? 13 cards, and how many are we choosing?
5.
5. So what happens is we're creating a compounding problem. We wanted 2 things to happen. We wanted to get the same suit and all 5, we pick a suit and all 5 cards to be of the same suit. So you have 4 suits, chose one, and we're going to multiply that to the 13 cards within that suit, choose 5. Now, did you guys know there is a button, the NCR button on your calculator?
Yeah.
I think it's right below the NER button.
Math.
If you put that in your calculator exactly the way it's written with the multiplication sign, it'll do it for you. What is it, like 5,000 something, or? am I pressing-
5,148.
So that means out of that 2 million, there are 5,148
148.
possible ways to get a flush. Now, seems like a lot of possible ways. There's 5,000 ways of doing it. But out of how many of them are there? So think about probability. We haven't discussed it. You probably haven't done probability in a long time. If you wanted to find a probability, remember how the ratio worked. You wanted favorable outcomes divided by total outcomes. Well, this would be my favorable outcome, right?
Yeah.
Our total possible outcomes was 2 million.
9,968.
What is it?
5,989,60.
2598.
960.
Thank you. So if I divide that out, that's the percentage possibility of getting a flush.
And then I have to multiply that. I'm
No. Well, yeah. So you get what? 0.19%.
It's closer to 2.
Whatever. It's still not going to happen. So the possibility of being dealt straight out a flush. Ugh, that's crazy. Okay.
Let's see if anyone gets it.
It's absolutely improbable. However, there's 5,000 ways that you can do it. So you start to think about it, it's like, wow, that's kind of crazy. Now, there are other more important ways. I think what beats a flush? A royal flush, right?
Yeah.
Because a flush beats a straight beats, is a straight beat 4 of kind?
Ooh, you just ignored me.
Hey! Does a straight beat a 4 of kind? Well,
Again, slower.
does
Yes.
straight cards beat a 4 of a kind?
I believe so.
Well, good answer.
Google it.
Thanks, Holden. That was helpful.
What class is this? What?
What shoes are you wearing?
Air Force Ones?
Not Heelys.
Yeah. I have a pair of Heelys. I don't know, let's Google it.
Go away. Go do your stuff.
He's helping us out.
No, I don't want to know.
Yes, you do.
So, you look at it.
As long as it's the same ones on the
Here we go. Ready?
Oh, let's do this.
Ooh, the Ace of Spades. That's in case you didn't know, that is the card of death, as well as a.
Jack of clubs.
No, what's the band? Motorhead. Motorhead song.
Google says yes.
Thank you, Google.
I said yes.
I didn't hear you.
Yeah, he said yes.
You were in the middle of your book, and I wasn't thinking you were paying attention.
I've been holding it
Alright, so wait, what class is this?
Science algebra 2.
I didn't get it.
I failed this class too.
Oh, Mr. Murphy, you had diamonds.
Oh, diamonds forever.
Hey, do you have Tyler Schultz in one of your classes? Do you? If you have Tyler Schultz, ask him to show you the card trick where you hold the cards like this. And he'll understand. It's really cool.
I got something to do. Goodbye.
You got some good cards in that
You
one.
ever play 52 card pickup?
Yeah, it was cool.
I picked on him so much. It's awesome.
Oh,
Wow. He might have a little extra chlorine on the brain. I get it. He might have been underwater for way too long, you know.
Every day.
A lot. He's a good kid. Just hold it. So what we're looking at here are these generic possibilities. I'm not looking so much into the probabilities yet, but I want to give you guys the idea of how you find them. I know you guys have done probabilities before. It's not horrible. Once again, why we had to multiply these things together was because we wanted two separate events to occur together. Okay? There's a difference here. When we're looking at the decision of multiplying versus adding, I'm going to show you an example here of when you do either of them. It takes a minute or two to understand how to read the problem, but once you do it, it's very easy. We know that we're going to multiply when we want how do we want to say this? When we want, it's like, how many other words can we put together with a W in it? When we want water.
We
want two events
multiply.
I was like, what's more?
to occur at the same time. What we wanted was, we wanted to pick all 5 cards same suit. So you had to, the first card had to be of one suit, then all other cards had to be of the same suit. If they weren't, you didn't work.
You almost had it.
Well, that would be pretty awesome. Okay? So that's what we're looking at. When we're talking about and, when we're going to add, when we add, they wind up being more independent choices.
Wait, like, where would we replace the multiplication sign?
Let me show you the actual problem that I have here that has them both. And you're going to see in the I want to say verbiage, but in the wording of it, it is very easy to distinguish between adding and multiplying. It is very, very easy to look at. Okay? Let me show you. A restaurant serving omelets with the following ingredients shown. You have vegetarian options and meat options. In the first question, it says, suppose you want exactly 2 vegetarian ingredients and 1 meat ingredient in your omelet. When you read that, it's telling you want 2 from the first column and 1 from the second column. So are you going to multiply that or add that? You're adding because you want both of those 2 things to occur. Okay? Now, if you read the second one, suppose you can afford at most 3 ingredients on your omelet. So that means you have, well, how many ingredients are there in total? There's 10 ingredients total. You can get an omelet with nothing in it, an omelet with 1 thing, an omelet with 2 things, or an omelet with 3 things. So you're looking at 4 separate scenarios that could occur. So those are 4 separate occasions versus I want 2 of these and this. I'm buying a car, I want my car to be red, and I want a sunroof. Sunroof. Sunroof.
Yeah, they
Sunroof.
I've never owned moonroofs.
There's a moonroof, there's a sunroof, there's a difference. A
a hole in the
sunroof,
roof.
Sunroof goes like that, and a moonroof goes like.
but sunroofs and moonroof, there are ones that do both.
Yeah. I don't know.
A generic sunroof was to be the one that just popped up. Okay? A moonroof is one that goes up or it can go back.
Across, yeah.
Wait, why is it called a moon?
Oh, because you can open it up to see the moon.
You can open up to see the sun. I mean, it's
No,
not over your eyes, but.
no, the original sunroof was the,
What?
That's what Allie did.
I know, it was just you guys were priceless on that one. What happens when you're looking at, back in my day, you could take your car that had nothing but roof and go to a place and they would cut a hole in your roof and put a sunroof in.
Charge you for it.
They would charge you for it. Now, those sunroofs were just like a piece of plexiglass glass with weather stripping around it that you would just pop up and you'd have a little vent. Then car manufacturers started putting in more and more sunroofs. And sunroofs nowadays are considered moon roofs because they're on a track. A motorized track, you press a button and it'll drop down and move back. Or it'll pop up and vent. Like the moonwalk, exactly. It's just gonna go.
Yeah.
Exciting.
That wasn't
Smooth,
too
like,
bad.
not bad for a really old white guy. Now, again, going back to the vegetarian versus meat things, you're looking at picking out 2 vegetarian options out of how many? 6. So to set this one up, you have 6 options, you're choosing 2, as well as picking 1 out of how many meat options? 4 times 4, choose 1. This is going to give you part A.
So it's multiplying it?
Yep, that's the multiplying one. Because you
I thought
want
you said this
this.
was adding.
I said that for the second one.
No, you flipped that.
Who cares? It's multiplication now.
It's saying it now, okay.
This one's multiplication. One of the reasons why you see that is because you notice the word exactly. You want this to occur. You want 2 from this one and 1 from this one. You're picking 2 from this column and 1 from this column. You have to combine them together. I wouldn't say combine, but you want to put them together with multiplication. Whereas the second one, it's talking about you can afford at most. When you see at most or at least, that means there are separate things that can occur. So if you want to get at most 3 ingredients, it does not say, does not constitute it's going to be specifically vegetarian or meat, just total ingredients. We know that there are how many total ingredients? 10 of them. So we would have 10 ingredients, choose nothing, you're just getting the flat egg, plus 10 ingredients, you can choose 1, plus 10 ingredients, choose 2, plus 10 ingredients, choose 3. That means you can pick at most 3 of them. Now, it may look like that's going to be a huge, huge number, but if you break it down into what the actual, remember what all these meant, this is 10 factorial divided by 10 minus 0 factorial times 0 factorial. That's 1. Okay? And so on and so it's very, very easy to set that up. Remember, your calculator has a
Well,
button.
because 10 minus 1 would be 9 factorial, and then you want that. No, I'm not saying you're wrong.
Then you just have
I'm saying-
10.
yeah,
So here you have
yeah,
you know, 10 factorial over 10 minus 1,
Yeah.
1 factorial. So yeah, you're right. This becomes 10. And the next one is,
Oh, you were doing the next one like after the plus sign. I thought you were simplifying the first one.
no, I'm sorry. Christian got ahead of us here. And the next one would be 10 factorial.
Over 10 minus 2 factorial.
Do you see why I wrote it at 8?
Yeah, 10 minus
I just wrote it out real quick.
7 and 3.
So this is 1, this is 10,
10.
this is 10, 9 over 2, so it's 18.
Wait, how'd you get
No.
that? 45. Can you simplify it so it would be 10 times
Yeah.
9? Over 2
You just
factorial.
have 5 times 9 because you simplify the 2 goes into 10, 5.
2 factorial, so you could do
Oh, why did I say 18? Yes, so it'll be 45.
5 factorial times
And the next one, it's 10, 9, 8 over 6, so you get whatever that is.
By the 6 and 9, so you get 3.
720.
3, 2 beats, so it's 1,220.
720 divided by 3 is 240.
Is that really what it is? I don't think that's it. It doesn't work.
Whatever it is.
6 and 9
All right.
are going to each
What I want to do tonight is, this is 12-2. Page 712.
It is 120 by this. Keep going.
That's a 126.
Numbers 126 to 30, 47 to 54, no 51. There,
It's 26.
26.
I lost my other one. I had it yesterday, but I lost it.
It is there. How's that?
Okay.
Very, very straightforward. What's
What
that?
is that between 60 and 126?
I don't know. I can't
Okay,
get
so how do you know what
For the complex.
Is that room that being?
Yeah, I can come.
Yeah, that's right. What's
Do you
that?
know when to add or when to multiply?
When you're adding when you're talking about at least, at most.
No, you said.
Okay.
You're multiplying when you want multiple things to occur at the same time. Okay.
Oh, you're right. At least